Okay, now let's look at the question required the least possible value of Manming height. So basically, it's looking for Manming height, which is at its lower bound. Okay, that basically is Manming lower bound. Okay, now what is this height? This height is 1.65 meter. Now what it's looking for is the numbers are up to trace significant. So we have to look at which position is the trace significant. So this is the third significant figure. Okay. So what is the number before this? The number before this will be 1.64. Okay. So that the number in between these two, the average value of these two, is actually the lower bound of Manming height. So it's 164.5. Sorry. Is 1.645 meter. Okay, there for this, so this answer is 1.645 meter. Now, next, let's look at the part B of the question. He wants to find the greatest possible difference in their height in meter. So yes, the original heights are in meters, so we will not make for a change. Okay, we will not make for a change. Now, let's define this first. The greatest possible difference in the height is you have to take one height minus the other one. But to find the difference, normally we take the one which is of greater value, which is ratio height. Okay, so it has to be ratio height minus Manming, which is the have a shorter height. Okay. Now, but if you want the difference in the height, the greatest possible difference. So basically, you are looking for the difference in the height for the upper bound of the difference in the height. Okay, to get the upper bound of the difference in the height, we would take the ratio height. We have to take the upper bound. To get a bigger value, then we have to take the Manming height at the lower bound. Okay. Now, we already have the lower bound of Manming height, which is 1.645 meter. Okay. Now let's look at ratio. Ratio height would be 179. Okay. Ratio height is 1.79. Okay. Now you want third significant figure, which is 9. Okay. We are looking for the upper bound. So upper bound is what's the number after this? So it's 1.80. So the upper bound will be the average of these two, which give you 1.795 meter. Okay. Now, so to obtain the value in meter, I just need to substitute the ratio height, which is the upper bound of the ratio height, which is 1.795. If I minus these two, I should get 0.15 meter. That's the answer. Okay. Now, if you want it in cm, then you just convert this into cm, multiply by 100, you get 15 cm. Okay. If you are curious enough, what about if I change this to cm and work out, see whether is it the same or not? Okay. Now let's do this. If I change Manming height to cm, it will be 165 cm, right? This is actually equal to 1.65 times 100. You are converting the meter into cm. So you want the lower bound of this. So before that, decide which position, which figure has changed. The third one, which is this. So the number before it is 164. So your lower bound is in between. We are looking for this value now, which is equal to 164.5 cm. Okay, this is the lower bound. Manming height lower bound. Okay, now let's look at Rachel. Rachel is 179. If you convert 179 meter, you multiply 100, you get 179 cm. Okay. Now we want to find the ratio height upper bound. So the third significant this. So the next number is 180 cm. So yeah, your upper bound would be at both. You divide by 2, you get 179.5 cm. Okay, using the same this equation here, whether it's cm or meter, you use the same one. Okay, so let's do it here. So the difference, you want the greatest in a difference of height, then you take the upper bound. Okay, which is this minus this. Upper bound of Rachel is 179.5 cm minus lower bound of Manming, which is 164.5 cm. If you minus them, you will get 15 cm. Okay, which is same exactly from the earlier one that we have done. Okay, that's it.